Hi, my name is John-Michael Colef, and I'll be doing problem 1 of homework 3. So, problem 1 gives us the probability that a customer or a number of customers arrive in a certain time period to be given by this Poisson process. So, the first part of the problem is we have to find lambda. We're given the information that the probability that in 2 minutes at least one customer arrives is equal to 0.5. So if we know that at least one customer arrives in 2 minutes, that the probability of that is 0.5, we know that the probability that no customers arrive in 2 minutes is 1 minus 0.5. So that's just 0.5. So now lambda is a constant, so it doesn't change regardless of what the conditions we put. So I'm going to say, this is problem 1, part 1. I'm going to say that the number of customers arriving in 2 minutes, I'm going to say k equals, so the probability, customers coming in, so time 0 to t, k I'm going to say is equal to 0. I'm saying the probability of no customers coming within this time, within 2 minutes. The probability of 0 customers coming in with 2 minutes is equal to 1 minus the probability of at least one customer arriving in 2 minutes, which is 0.5. So it's 1 minus 0.5, which just gives us 0.5. Now we know 0.5 is equal to our equation over here, which is e to the minus lambda t times lambda t to the k over k factorial. So we know that t is equal to 2 because we're dealing with a case where it's 2 minutes, and k is equal to 0. So we have 0.5 equals e to the minus lambda 2, because we're in 2 minutes, lambda 2 to the 0 over 0 factorial. This becomes 1 and the bottom becomes 1, so we're just left with e to the minus lambda 2 equals 0.5. Take the natural log of both sides. So natural log of 0.5 equals minus lambda 2. So then lambda is just equal to natural log of 0.5 divided by negative 2. And if you plug that in your calculator, you will get 0.347. So that's our value for lambda. Okay, part 2 asks, find the probability that in 10 minutes at least 2 customers will arrive. So the probability of at least 2 customers arriving is, you can also write it as 1 minus the probability, so I'm just going to put a bracket here, 1 minus the probability that 0 customers arrive, so 0 customers, plus the probability that 1 customer arrives. So we can find these easily. It's not so easy to find the probability that at least 2 customers will arrive. So we'll do the as Professor Rappaport calls it, the backdoor method. So probability that 0 customers arrive, well, we just plug into the equation, and this is in 10 minutes. So 10 minutes. 10 minutes. So in the probability of 0 customers in 10 minutes is just going to be lambda we have. I'm just going to leave it as lambda here for now. T is 10 minutes. Lambda 10 minutes. K is 0 because we're looking at 0 customers over 0 factorial. This becomes 1. So we're just left with e to the minus lambda 10, which if you plug in all the numbers gives you 0.03125 roughly. Now, the probability that 1 customer arrives in 10 minutes is going to be, again we follow the formula, e to the minus lambda 10 to the 1 because now we have one customer, and then we have 1 factorial. So this just becomes e to the minus lambda 10, lambda 10. And that gives you, if you plug it in your calculator, 0.1083. So the probability at least 2 customers arriving in 10 minutes is simply 1 minus the sum of these two. So it's 1 minus the sum of 0.03125 plus 0.1083. And the result is 0.86. Okay. Now it's this page. Okay, so now we're going to do part 3 of the problem. Part 3. They asks, find the probability that in 1 minute exactly 1 customer will arrive. This one's really, it's much easier than the previous part because we can just plug in the values. So probability of 1 customer in 1 minute is just going to be e to the minus lambda, t is 1, lambda t, 1 customer over 1 factorial. And if you plug in the numbers, you just get 0.245 as your value. Now, probability that part 4. This asks for the probability 0 customers arrive in 3 minutes. Again, much easier than part 2 and part 1. 3 minutes. Well, we just plug into the formula. We have e to the minus lambda 3, lambda 3 to the power 0 over 0 factorial, and we just get 0.354. You plug in the numbers. So that is the end of problem 1.